Today we finished up lesson 5 using scaled copies and similar triangles. And so just a reminder, we were applying scaled copies to different scenarios. And today specifically we're going to look at something called the mirror method and the shadow method. There's a method to measure heights of objects that we can't reach using a mirror. And so we place a mirror a certain distance from the base of the object, and then we walk backwards until we can see the top of the mirror the top of the object in the center of the mirror. And hopefully we know our own height and we can measure the distance we are to the center of the mirror. And that'll allow us to find the height over here. And you can see our two triangles just like we had in the previous problem. And again, we have a right triangle with these two angles being equal. We have our right angles, which means our third angle also has to be congruent. And so Aaliyah wants to measure the flagpole at her school. She puts a mirror on the ground 20 feet from the base of the flagpole. She then walks backwards from the flagpole while looking at the mirror. She stops when she just sees the top of the flagpole. She is now 5 feet from the mirror. If Aaliyah is 3 feet tall to her eye level, how tall is the flagpole? So if we sketch this out, here's our flagpole, and we put our mirror on the ground, and we're measuring the distance from the flagpole to the center of the mirror. That tells us that it is 20 feet. And you can see we're making a triangle here from the top of the flagpole to the mirror. And then Aaliyah walks backwards until she can see the top of the mirror, or the top of the flagpole, in the center of the mirror. And she ends up 5 feet from the mirror. And she is 3 feet tall. So thinking about what we just talked about, the distances from the mirror are corresponding sides, and the heights are corresponding sides. So we can use what we've been learning to find how tall the flagpole is. So since my missing side is over here, I'm going to find the scale factor from the small one to the big one. So in this case, my scale factor is 4. And then we just multiply 3 times 4 to get 12 feet tall for our flagpole. There's another way we can use triangles and scaled copies to find heights that we can't measure using the shadows from the sun. And again, thinking about angles in the triangle, in both cases, the object is making a 90-degree angle with the ground. And this time we use another object. You could use your own self and look at your shadow as well. But again, you're 90 degrees from the object to the ground. And the sun's rays, even though we can't see them, are all parallel lines, which means that these angles over here are also equal, and the angles at the top are also equal or congruent. So again, we have scaled copies because all the angles are congruent or the same. So Marcus wants to measure the height of our flagpole. So again, I like to draw pictures. So there's our flagpole. He notices that at 5 p.m., his shadow while standing next to the flagpole is 3 feet, and the flagpole shadow is 20 feet. And so he's standing here. His shadow is 3 feet. Probably shrink this down a little bit. And he is 5 feet tall. And I can connect. I'm using dotted lines because they're not really, the objects aren't really there. And we're trying to find the height of the flagpole. So again, I'm going to find the scale factor from the small one to the large one, find it to the side that's missing. So my scale factor equals 20/3. So then I do 5 times 20/3, which gives me 100/3. And we wouldn't leave 100/3, so we're going to change it to 33 1/3 feet. Don't forget the label, like I did.